Good morning. Today we are doing the first half of chapter 5.5, which is writing equations of parallel and perpendicular lines. To start, we're going to look at just the parallel lines, and then a little bit later we'll look at perpendicular lines. First, if two non-vertical lines, so not vertical up and down, in the same plane have the same slope, then they are parallel. So if I was to graph two lines, one like this and another like this, if they have the same slope, meaning they're angled the same rise over run, or the same m slope, then they have to be parallel lines. They're never going to touch. And the same is true if you have two non-vertical lines in the same plane that are parallel. If they are parallel, then they must have the same slope. This is called the converse. It just means the opposite of what was just said. Well, if they have the same slope, then they're parallel. Well, if they're parallel, then they must have the same slope. Not shoes converse, it just means in math the opposite or the inverse here. And this symbol that is repeated down here, this is just meaning parallel. So if you have line A parallel to line B, you would say A is parallel to B. So let's look at a couple equations of parallel lines. It says write an equation of the line that passes through the given point and is parallel to the given line. And it says parallel lines have the same slope. That's something that we know now. So here's our point that we want our equation to go through, and here's one equation. So they're giving us one line, let's pretend they already graphed this line right there. Now we need to find the other line that's parallel to it. So we know that if they're parallel, they have to have the same slope. Well, this equation is in the form y equals mx plus b. Well, so what's our slope? Our slope is in front of the x, that's really a negative 1. So our slope is a negative 1. Let me fix that there. There we go. So we know our slope is negative 1, so with our new equation, our second equation, our slope also has to be a negative 1 because they're parallel lines. So let's use our point x, y, and our slope to write an equation. I'm going to start with point-slope form because I have a point and a slope. So point-slope form is y minus y1 equals our slope, and x minus x1. So I'm going to plug in what I know. y1 right here is 11. Our slope right there is negative 1. And then x minus x1, which is a negative 2. Two negatives make a positive. And I'm just going to distribute because we want our equation in this form, y equals mx plus b. So I'm going to distribute these, negative 1x. Negative 1 times 2 is negative 2. And then the opposite of subtracting 11 would be adding 11. So those go away. We have y equals, this looks like a 4, it's a y, a negative 1x. And then 11 minus 2 is 9, or negative 2 plus 11 is 9. So here's our equation of our new equation that would be parallel to the one that they gave us. Let's do the same thing over here. They give us a point, x and y. They don't tell us what our slope is here. This one is not in the form y equals mx plus b. This is really in standard form with x and y on the same side. You can't figure out your slope. Do not tell me it's 5 because it's in front of the x. That's not correct. You can't do that unless you have it solved for y. So I'm going to move this 5x over to the other side. I'm going to solve for y. I have negative 10y equals negative 5x plus 3. And the opposite of multiply is divide. So y equals, well, two negatives here make a positive. And 5 over 10 we can simplify by dividing by 5. That's the same as 1/2. So we have 1/2 x. And then 3 divided by 10, we can't simplify that, so it's still just negative 3 over 10. We don't care about the 3 over 10. The only thing we wanted to find from this was our slope. And our slope in front of our x, our m right there, is 1/2. So there's our first equation. Now we need a second equation. We'll move this over just a tiny bit. With our slope, that's 1/2, and it goes through this point, negative 9/11. So I'm going to use my point slope form. Y minus y1 equals our slope, x minus x1, and plug it all in. So y minus y1, which is 11, are equal to our slope, which is 1/2, and x minus a negative 9. Those two negatives make a positive. And then let's do a little distributing. 1/2 times x is just 1/2 x. Half of 9, well, that's a tricky one. Half of 8 is 4, so half of 9 would be 4.5 or 4.5. And then we need to add 11 over to the other side. So we get y equals 1/2 x plus, these are all positives, 11 plus 4 is 15, and we have the half, so 15.5. There's our equation. Both of these lines would be parallel to each other if we were to graph them because they have the same slope. So there was just an introduction of parallel lines. Now we're going to look at perpendicular lines, and this is the symbol that means perpendicular. If two non-vertical lines in the same plane have slopes that are negative reciprocals, then the lines are perpendicular. Well, if one of ours is negative and the other one has to be negative, that just is really looking for the opposite. Because if one of our slopes is negative and the other you have to take the negative, well, two negatives make a positive, so the opposite of a negative is a positive. So when they say negative reciprocals, that just means opposite reciprocals. Or reciprocal, meaning we're taking our fraction and we are flipping it. It says the same thing here. This is the converse. If two non-vertical lines in the same plane are perpendicular, then their slopes must be negative reciprocals or opposite reciprocals. So it says find the negative reciprocal. So here our slope is 5. So our perpendicular slope, the opposite reciprocal, instead of positive, it would be negative. Instead of 5 over 1, our fraction flipped, or the reciprocal, would be 1 over 5. So this one, our slope is negative 3 over 2. So our perpendicular slope would be, instead of a negative, a positive. And instead of 3 over 2, we need to flip that and make it 2 over 3. This is telling us that these two lines, if we were to graph them, one would have a negative 3 over 2 slope, and the other would have a positive 2 over 3 slope. Those lines would be perpendicular, meaning they cross at 90-degree angles, or right angles. And our last one here, if the slope is 1/9, our perpendicular slope, or our perpendicular line, instead of positive, would be negative, and instead of 1/9 would be 9 over 1, or just 9 over 1 is just 9, so negative 9. So here's just a funny joke. These cats are sleeping perpendicular to each other because they would cross at right angles. Alright, next write an equation of the line that passes through the point and is perpendicular to the given line. So here's our line. Our slope in this line is negative 1/5, but for our new line, we want a slope that is perpendicular. So over here, our perpendicular slope, instead of negative, would be positive. Instead of 1 over 5, it would be 5 over 1, or just 5. So I'm going to use my point, x, y, and my slope to write an equation of the line. I'm going to start off with point slope form because I have a point and a slope, just like we did for parallel lines. The only difference is our slopes are opposite reciprocals. So y minus y1, which is a negative 7, those two negatives make a positive. Our slope is 5. And then x minus, I'm just going to get rid of this line, x minus 3. So then let's distribute. 5 times x is 5x. 5 times negative 3 is negative 15. And then subtract 7. we have y equals 5x, and then these are all negatives, a negative 15 and a negative 7. We're going to add them all up. That should give us a negative 22. So there is our equation of a line that is perpendicular to the original line that they gave us. So this line and this line are perpendicular. I would like for you to try this one on your own. Solve for y first in this equation, because you can't tell what the slope is. You need to solve for y, find the slope, and then write an equation of a perpendicular line. So first, if I'm solving for y, I'm going to subtract 10x. So I have negative 5y. And you can't combine these. One has an x and one doesn't, so negative 10x plus 6. And then divide everything by negative 5. We have y equals, well, two negatives here make a positive. 10 divided by 5 is 2, so 2x. And 6 divided by negative 5, if I know it's negative, I don't know what 6 over 5 is. If you want to convert it to a decimal, that's fine. But I don't really need to know what that is, because the only thing I care about is the slope, which is 2. But now if we want a line that is perpendicular to this line, instead of a positive, our slope would be a negative, and instead of 2 over 1, our slope would be 1 over 2. So here's my point, x, y. I'm going to plug it in to my point slope form, because I have a point and a slope. So y minus y1, which is 2, equal to our slope, which is negative 1/2. And x minus x1, which is a negative 9. Those two negatives make a positive. And then let's distribute. Negative 1/2 times x is just negative 1/2 x. Negative 1/2 times 9. We did this earlier. I know it's negative. Half of 9, well, half of 8 is 4. Half of 9 would be 4.5. Oops. And then our last step, it says y minus 2, so we need to add 2 to the other side. So we have y equals negative 1/2 x. Well, these are negative and positive opposites. We need to subtract. 4 minus 2 is 2. And we have the 0.5 left over. There's more negatives. We just did the bigger number minus the smaller number. We know there's more negatives. And that's our answer. Y equals negative 1/2 x minus 2.5. If you're still not sure about those negatives and positives, plug it in your calculator to double check. But this line is perpendicular to the original line that they gave us. We just solved it for y. Alright, a couple more. It says determine which lines, if any, are parallel or perpendicular. In order to determine if lines are parallel or perpendicular, we need to look at their slopes, their m. So this one is already in the form y equals mx plus b. So our slope in this line is 8. This one is also already solved for y. It's in the form y equals mx plus b. So our slope is 1/8. And then last, this one is not solved for y, so we need to get y all by itself. I'm just going to subtract the 8x over to the other side. And we have y equals negative 8x plus 2. Now that it's solved for y, our slope is a negative 8. So here we have our three slopes. I need to determine which ones are parallel or perpendicular. First, let's look at parallel lines. Do any have the exact same slope? 8 and 8 look close, but this one's negative and this one is positive. So there are no parallel lines. And this means parallel again, remember? There's two lines that are tilted. But perpendicular lines. What about those perpendicular lines? Are any opposites, one negative and one positive? Well, here's a negative, so either of these could be opposites in that sense. But instead of 8 over 1, which one's 1 over 8? Well, this one right here is. So B and C, they're opposites, negative, positive, and flipped. 1 over 8, 8 over 1. So line B is perpendicular to line C. That's our answer. I would like for you to try this next one down here. Solve them all for y and determine which lines are parallel and which are perpendicular. I know right away line B and line C are in the form y equals mx plus b, so I can figure out my slope right away. This one my slope is 1/3. This one my slope is -3. I actually have to solve this one to get y by itself. So I'm going to subtract that 6x. We have 2y equals -6x plus 5. And then divide by 2 to get y all by itself. 6 divided by 2 is 3y. Oops, not 3y, 3x. And it's negative. And 5 divided by 2, 2 goes into 5 2 times, and one more, 1/2, or 0.5. I'm going to write 2.5. So my slope, now that it's in the form y equals mx plus b, is a -3. So are any of these parallel lines? Well, right here, this is -3 and this one is -3. So line A is parallel to line C. We also have some perpendicular lines. This one is negative, this one is positive, so those are opposites. And instead of 3/1, we have 1/3. So line A is perpendicular to line B. But guess what? Isn't line C also perpendicular to line B? Because this is negative, this is positive, and 3/1, 1/3. So line B and C are also perpendicular. It doesn't matter which one you put first, we just normally put them in alphabetical order. So these two really mean the same thing. So we need all three of these written out for our answer. A and C are parallel, A and B are perpendicular, and B is perpendicular to C as well. Our last problem, this one I believe is also on your homework. It says you are beginning to model a kite design on the coordinate plane as shown. Write an equation that models part A of the kite. Well, equation, we want the form y equals mx plus b. Let's see if we can find those things. Here's line A. First we need to find our slope, or m. So I'm just going to count rise over run. Rise, 1, 2. And we're running 1, 2, 3. So our slope is 2/3. And our b, where we're crossing the y-axis, or our y-intercept, is right here. That would be really at the number 4. We're crossing the y-axis at 4. So our equation would be y equals m, which is 2/3 x, plus b, which is 4. There's an equation of the first line. Now it says write an equation of that models part B of the kite. And some of you might be thinking, how does this make a kite? Well, if you drew the other half, this would be a kite that you could fly in the air. But we just want to look now at this second line, line B. So we still want an equation in the form y equals mx plus b. So let's first find our slope, m. So we're rising or going down 1, 2, 3, 4. We went down 4 and over 1, 2, 3. And then our b, where we're crossing the y-axis, our y-intercept, is right here. It also is at 4. So our equation here is y equals -4/3 x plus 4. So looking at these two equations, do the kite parts form a right angle? Well, what do we know about right angles? Right angles are 90-degree angles. We also call those perpendicular lines. So that means the slopes have to be opposites and reciprocals. They have to be opposite reciprocals. So let's look. This one, our slope was 2/3, and this one, our slope is -4/3. They are opposites in terms of negative and positive, but they're not reciprocals. One is 2/3, and the other is 4/3. So, do the kite parts form a right angle? No, because it says justify your answer. They, meaning the slopes, are not opposite reciprocals. There we go. Your homework is out of the book. If you have questions, please let me know.